Welcome to another rendition of Math is Easy Step by Step. Here I'd like to go over some more examples with adding and subtracting with exponents. So let's take a look at number one in review from the last video. In order to add or subtract, you have to have the same base. That's the same variable or letter. And it has to have the same exponential power. That makes them like terms. We also talked a little bit about invisible ones. So show those invisible ones. If you need to go back and review the video prior, hey, help yourself. Go slow. Take your time. So here we have z and z. Both of these exponents have the same variable, z. So it's the same base. And they're both to the power of 2. That means we can add the number in front of those letters called coefficients. So 3 plus 5 is 8. You simply just keep the z attached to that 8 to the second power. There is your answer for number 1. So in problem number 2, I like to try to break this down a little bit further in trying to simplify these terms. Now, the bases are the same, right? And I just wanted to explain what this all means. Okay, we have 3 and 2. The bases are the same. However, the exponential powers are not the same. And if you haven't seen my video on multiplying with exponents, I want to show you how you can break this term down, 3 to the second power and 2 to the fourth power, in its most simplest form, which is called expanded form. So 3 to the second power means 3 times 3. So I'm going to show you that here, 3 times 3. So if you're ever asked to simplify a problem like this, you absolutely can. Plus, plus. 2 to the fourth power means 2 times 2 times 2 times 2. So 2 times itself 4 times. That you can see that here. So 3 times 3 is 9, plus plus. I'm just going to rewrite that. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So to simplify this further, we can add these two terms together. 9 plus 16 equals 25. Example number 3, you can see here. We're going over these, adding again with exponents. We have a base of y and a base of y. The bases are the same. Before I do anything, if there's no number in front of your letter, why don't you show that invisible one? We talked about that last time in the prior video. If you don't have an exponent, hey, show that invisible one. But here we do have an exponential power of 5. So we're checking to make sure the bases are the same, y and y is the same, and the exponential powers are the same. Hey, we can add these two terms, or coefficients, a number in front of the y. 1 plus 1 is 2, and then we keep the same base to the same power together. 2 and y are attached through multiplication, so they just stay with the answer. Moving forward. Let's take a look at number 4. And then we have a problem number 5. We have 5x plus 10x plus 25x. And again, show your invisible ones. There is a power of 1 attached to that x, even though it was invisible. I'm telling you, write it in there, dot, 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 or just write a straight up 1, right? Show your invisible ones. If you want to put a 1 here so you can see it, absolutely do that. It's going to help you out, right? So we have 5x to the first power plus 10x to the first power plus 25x to the first power. We have the same base of x in each of the terms. We have the same exponential power. And by the way, each of these terms is separated by a plus sign, and that's a positive 5. So 5x to the first power is a term, positive 10x to the first power is a term, positive 25x to the first power is a term. So now we have all the same base, the same exponential powers. 5 plus 10 is 15. 15 plus 25 equals 40. and we just keep that same base x with the exponential power, 40x to the first power. Now many answers will just be 40x. I don't know why, but they don't really show that invisible 1 typically in your answers, but it's perfectly okay. It means the exact same thing. All right, moving forward, I wanted to give you an example here. So for number 5, we have 12x squared plus 15x cubed. Now, are these the same bases, x and x? Yes, they are. Are these the same exponential powers, 2 and 3? No. Because they don't have the same exponential power, you cannot add or subtract these two terms, right? You must have like terms in order to add or subtract with exponents. So since they're not like terms, you cannot add or subtract. You can only add or subtract like terms, and these terms are not like terms. So you just circle this answer. It would be simplified to the fullest, unless they gave you a value of x, and then you could substitute that. Hey, check out my substitution video. I have not created that yet, but I will be creating that shortly, along with some high set and some GED test questions with examples of how to answer those questions in the near future. So let's take some look at examples of subtracting with exponents. Again, show those invisible ones. Show those invisible ones. Here in example number 1, I got 35c minus 18c. Well, there is a power of 1 associated with that c. You can show an invisible one like I did here, or you can just write in a solid 1 in that exponential's place. Do we have the same base? Yes. Is it to the power of 1? Yes. Remember, it's an invisible 1. Okay, so then we can subtract or add the coefficients, the number in front of the letters. 35 minus 18 is 17. We now would keep the variable c with the 17, and remember it's to the first power. So many times you'll see the answer 17c. Is it okay for you to write in 17c to the first power? Absolutely. It's the exact same thing. All right, let's take a look here at example number 2. We have 4z to the 10th power minus 5z to the 10th power. Do I have the same base? I do. Z is the base. Do I have the same exponential power? I do. These are like terms. 4 minus 5 is a negative 1, right? It's an invisible 1 typically. Can you write a solid negative 1 in front of that z? You absolutely could. So think of it this way. 4, you have $4. And then you minus 5, you owe $5. How much do you still owe? You still owe that $1. That's a negative 1. Okay? Keep the base, keep the power in your answer. It's attached by multiplication. That's number 2. Let's go ahead and take a look at a third example here. So we have 10 squared, 10 to the power of 2, times, that means multiplication. When terms with numbers and terms are attached like this, it means multiplication. A to the first power minus 15 squared times a to the first power. Are these two terms like terms? Well, we have a and a. The base is the same. The base is the same. We have say a whole number called a consonant, right? Whole numbers, that base is the same. It's to the power of 2 here. It's to the power of 2 here. So yes, these are considered like terms. So then you just focus on the coefficient. That's the number in front. We got 10 and a negative 5. You put those together, you're going to end up with a negative 5. Hey, you got $10. Hey, you owe me $15. You paid me the 10. How much do you still owe me? That's a negative $5. And it's to the power of 2. So we keep that in our answer. These coefficients are attached to the variable a to the first power. So negative 5 to the second power. attached to a to the first power. Hey, that's going to be your answer. That's going to be your answer. Let's take a look here at example number 4. We have 33p minus 3p equals, well, let's take a look. Are these two bases the same? We have p and p. Yes, those bases are the same. And they're both to the invisible exponential power of an invisible 1. It's not shown there in many of the problems. So you, to make things easier, should write in that invisible 1. If you didn't see my video prior, please take a look at the adding, subtracting exponents rules. I go over invisible 1s very briefly in that video. And in previous videos, I've just spoken about the invisible 1 and the power of showing that invisible 1. It helps to eliminate a lot of confusion. So here we got a base of p to the power of 1. Yes, these are like terms. So we just subtract the number in front of the variable p. So 33 minus 3 is 30. And then we keep that variable attached. And yes, that is to the first power. Is it okay if you write a exponential power of 1 here in your answer? You absolutely can. It means the exact same thing. You can only subtract like terms. Okay, so some letters or numbers, they need to have, in order to be like terms, they have to have the same exponential power and the same value. Hey, this is another rendition of Math is Easy Step by Step. I hope you found this video helpful.